A couple of weeks ago, we let a wheel and axle roll down a ramp, which started our exploration into uniform acceleration. Most students did this during class and also did the experiment through Pivot, or maybe had both their trials through Pivot, where the wheel and axle was speeding up in a positive direction. As people collected data from either of these experiences, they built time and position data table.
And the position versus time graphs that people built had a top open curve. And we know that the slope of any position versus time graph tells us the velocity. And so by looking at tangent lines of this, we could say that at time 0, the tangent was 0, or the velocity was 0. A little while later, we draw a tangent line, and it's some positive slope, and we get a steeper positive slope. And so we've got a velocity versus time graph. So we've got a constant increase in velocity. In analyzing that, we found just like the slope of a position versus time graph is velocity, and the y-intercept tells us the position when time equals 0, the slope of a velocity versus time graph describes how the velocity changes, which we say is acceleration, simply describing how velocity changes with respect to time. And we know that the y-intercept of a velocity versus time graph would tell us the velocity at time 0. So, a little while later, we found out that for a uniformly accelerating object, the average velocity for the time interval equals the instantaneous velocity at the time in the middle. And we built that crazy data table that had like clock readings and position and change in time and change in position and average velocity and time midpoints. And we built a new velocity versus time midpoint graph. And the shape of this graph was exactly the same as it was from the velocity versus time graph from tangents. And the slope, again, showed us the rate of acceleration. The y-intercept told us the velocity when time equals 0. Same thing as writing velocity when time equals 0, same thing. The other kind of graph that we built, we found out that scientists, when looking at position versus time graphs that had a top open curve, you could linearize those graphs if you squared what was on the x-axis, which in our case is time. And so we made a position versus time squared graph. We found out that the slope of that was half of the slope of our velocity versus time graphs, which we already knew were acceleration. So the slope of that graph ended up being represented the 1/2 the rate of acceleration. What does the y-intercept of this graph tell us? Well, it tells us the position when the clock reading squared equals 0. But when would the clock reading squared equals 0? Well, it would be just when the time is 0. So it's telling us the starting position, just like for our position versus time graph. That was a quick review.